All right, time for the second lecture of the week, and this one is a bit at a higher level. It's less nitty-gritty, more big picture stuff. All right, so we're going to talk about software development, the life cycle of software development, how it lives and grows and dies, I guess. So I have definitely stolen most of this, a lot of this information from Bill Kearney's wonderful slides, so please take his classes too here. He's a wonderful instructor. So let us get started. I am going to give you $1 million. I wish I had $1 million to really give you, but let's pretend that I did. And I say you have 1 year to make me some piece of software that I want, some app, some website, some wonderful next big thing that's going to make me rich, but you get $1 million out of the deal. Okay? What do you do next is the question. All right? And a lot of different theories have been made for figuring out, okay, what should we do now? How do we plan this software? How do we get the exact thing that the customer wants out the door? So let us talk about these things. So this is kind of the plan that most people would come up with. All right, so this is the traditional way of writing software. All right, so the first part is gathering requirements and making some kind of analysis of what you need to do. Okay, and so here's a nice pretty picture at the right. We're in the red at the moment. Okay, so if your customer wants an app, you need to ask them a whole lot of questions. You better meet with them every day to figure out what they really want. You got to talk to them. Like, what do they want this button to do? All that fancy stuff. Figure out how the software will be used, okay? And the technical term for that is the use cases of the software, okay? So figure out all the ways that this thing that needs to get made is going to be used, and only then do you even know what to write, okay? Only then do you even know what to plan to write. So this is like, this is taking 1/6 of your year, right? This is 1/6. That is 2 months, 2 out of 12, right? And that is just gathering requirements, analyzing what you need to do to make sure that when you actually start coding, you're going to be doing the right thing, right? So that is very, very necessary, gathering those requirements, and that takes some time. You wouldn't just jump in and start coding, okay? This is not like a lab for this class, right? So that's 2 months, and then another equal amount of time, another 1/6 of your year, would be not yet coding still, right? Just figuring out, okay, going from these use cases to the actual design of the software you're about to write. So we were in the red state, now we're in the green state. Okay, it is it's a finite state machine. Huh. So you have to, in this stage, maybe you're done talking to the customer, you need to figure out how all of the little pieces of your software are going to hook together. Okay, it's like, okay, I'm going to write this class, it's going to talk to this class, who's then going to talk to this class, and maybe it does some stuff by itself, and then it gives back a chunk of information back to the original person. That's the idea. And then there's like some weird network systems over here that talk to each other. It's just a big mess sometimes, and you need to plan all this out so that it doesn't seem like a mess anymore. Okay, and so that's specification generation, we say. All right, so you need to figure out exactly what the code that you still haven't written yet, what it needs to do. All right, you plan out all your classes, every function as well, every method, every class, and you write down maybe some documentation, what it's going to do, and like what you need from other people, because you're usually working as a team, right? So you need to plan all of this stuff very, very carefully. Otherwise, you're not going to hit the requirements. You're not going to do the thing correctly unless you plan ahead. Okay? So that is the design phase. And then you finally get to implement. Okay? And this is going to take 3 out of 12, so a quarter of your time. That is relatively a lot, but it doesn't seem like a lot, right? You'd think that, okay, we're going to write code for a year, but that's not actually what happens. You spent a ton of time up front, more time than you'll be writing the code, to figure out what your program's going to do. Make sure you know what it needs to do, make sure you know how it's going to do it, and then you can give it off to all the programmers that work for you, and just hope that they're going to implement those specifications that you came up with in this stage. Okay, that's where the code writing begins, and then you're not done, right? It's like, okay, we've implemented everything here. Your software's done. Let's go have a vacation for the rest of the year. That is not what happens, because you will make mistakes. Even if you planned everything perfectly, mistakes will be found in the process. The use cases will maybe fall apart in some cases. It just, nothing's perfect from the get-go. And so it requires a whole lot of testing. Just as much time as coding. Isn't that crazy? So now we're here. That is the testing process. You need to go back, okay, look at the specification, and actually test the code. So that's what I'm doing in your labs, right? I'm making sure that the stuff I asked you to write, the functions and the classes and the methods, they're actually doing the right thing, okay? So that is very necessary. These are your unit tests, right? And then you have also more cohesive tests or bigger tests that bring together a bunch of things. So you then make sure that they all work together properly after you've made sure they each individually work properly, okay? And so it's kind of like a stage. Make sure this is going right until, and then you're ready to do this one. And then finally, you can actually test the program with people. Like your testers are actually clicking all the real buttons, everything's in the right place, making sure that it follows these use cases properly, okay? So it's all in that order. All right, so testing needs to happen. It needs to take just as long as writing code, if not more. And that is the truth. You can make a lot of money just testing code for the rest of your life if you wanted to get into that. I think it's fun. It's like you're hunting down all the bugs. You're like a detective. So a lot of the year is over now. Okay, 6, 7, 8, 9, 10. You've used up 10 months now, and you got 2 left. What do you do now? So at the very end, you give what you have, like you make a beta version, you give it to the customer, okay, in the 11th month. So this is to make sure that what they set up here is still what they want now, and it probably won't be, and just let them try it out and give you suggestions, because they're going to have suggestions. They're going to notice things that they didn't know they needed before, but they need now, okay? Or they're like, okay, I want to change this. I want it to be in this layout. Things like that. So you got to give it to the customer. You can't just, okay, take the 12 months, give them something, and expect them to pay you. Okay? It needs to be to their liking. So you give it to them early. And then, after all of that, both of these at the very end are called the evolution process. Software's evolving. It's more or less made, but it needs to evolve to be perfect, I guess. And then the rest of your time, and it probably will go over even after you've shipped it to the customer, because they want you to like keep track of it and make sure it's all still working and maybe add features, is debugging. Okay? Debugging is key, because the customer will find bugs that they didn't know about when they first got it, because they're now going to give it to a bunch of users that they wanted to give this program to originally, and then they're going to request features, like I said, as well. Okay, so there will be more bugs, there will be more features to implement, and they're going to end up giving you a bunch of requirements. And so this is the cycle of this software. It's going to start all over again. So like, okay, I want all of this new stuff, and then you begin the cycle once more. Okay? So that is the traditional way to write code. I think if I gave you enough time to plan all this stuff out, you'd come up with something very similar to this. Okay? It is a useful kind of thing. Okay? It's a useful kind of thing to want to do, and after you do a couple projects, you'll understand finally why testing is so darn important. Okay? So that is the steps. Now let's talk about the different ways to do things. This is just the life cycle. There are different ways to manage this life cycle, and we'll call those programming paradigms. They each have different fun names, and they each ask something different of the programmers, of the people in charge, okay? And so different kinds of companies or entities, they gravitate towards a certain kind of paradigm because it kind of maybe matches their culture, we can say. So the very first one that I want to talk about is called Waterfall. And so after I get a drink of water, I will talk about it. So this is a very traditional, it's the most traditional, it matches this the most traditional A lot of people hate this one. Many programmers hate Waterfall, hate this paradigm, but it does have its place. So let's go and talk about the waterfall method. All right, on to these slides. So waterfall is all about doing those steps that we talked about in order. Okay, so really what I gave you up here was the waterfall method. And it was pretty intuitive, right? It does make sense that you might want to do it like this, but it does have quite a few downsides. All right, so let's talk about those. So the pro, though, very nice thing about waterfall, first the requirements, then specification, then actually do the programming after designing and coding and testing, all this stuff. Everything is planned out. It's all specified. You know what exactly needs to happen. So, for example, if you're writing the control system for an airplane, you're probably going to go with the waterfall method because you want to make sure that every little thing has been specified before you even start coding. You are risking people's lives if it's not perfect, okay? So waterfall method has its place, but a lot of the time, waterfall just doesn't work out properly, okay? When people's lives aren't on the line, waterfall becomes a bit excessive, okay? So it's absolutely not flexible. So maybe the user comes to you in your design phase and they're like, okay, you know what, we were wrong about our initial problems that we were trying to solve. Our use cases that you wrote down from us back a few months ago, they're just completely wrong now. We're going to need you to do completely different things, or we'd like you to add this major new feature. You then, if you're doing waterfall, you got to wait till the next round, man. It's just not going to work. It's just not going to work. You can't section off, have a couple people be doing requirements analysis while some other people are doing design. That's not how the method works. Okay, so it's not happy. You're not happy. The customers aren't happy. It's just not flexible. And the main reason is because the customers don't know what they want. Okay, that is usually the case when waterfall projects are delayed or just things go wrong. Okay, usually it's because the customers don't know what they want, but also because the programmers, you usually have a ton of them. They're all working, they're down in the trenches. They might notice that something needs to change. It would be easier to do this thing in a different way. It would cover more bases, but no. We've designed this entire software already. It's not changing. So it's just too set in stone for a lot of projects. Okay, for some it has its place. It's a good method for those, but a lot of the time it's a little too hardcore. It's not what you want. So enter a different paradigm. Okay, enter a paradigm called Agile Development. Okay, so here's a nice meme that you will understand by the time I'm done explaining it. But Agile is all about responding to changes. It's like, okay, you're agile, you're jumping around, right? This responds to changes a lot faster than the waterfall method does, because you're not spending a year to do all this together. You're spending very, very short amounts of time. Okay, so Agile, it uses the same cycle that we were talking about, this nice little cycle, but it does it super duper fast. It's not a year for the whole thing. It's about a month for the whole thing. Okay, so they work in very, very small chunks, so they get small pieces out the door very quickly. Okay, that's what Agile Development gives you. You may have heard of it. It's a nice buzzword these days still. So yeah, the pros of this is that the clients can see exactly what you're working on very quickly. They can give you feedback to say, okay, yes, that's what I had in mind, or no, we need you to change that. And you don't have to wait a year to go back and change it. Okay, that's the beauty of it. Cons, though, are unfortunately some bad things can still happen with Agile. Okay, because you're working so quickly, a lot of your programmers, and you haven't made a very strong design decision, some of the programmers, a lot of the time, if you know us, we all like to focus on the cool new things. Like, I want to try all this fancy new web language technology, all this stuff. Can we do that, please, boss? And they're going to maybe lose sight of the real goal. Okay, so that's one thing. And then also it's perceived to be a lot more stressful doing work like this because of all the shorter time frames. You have to ship something in like a month rather than a year. Okay, so it's a bit more stressful, and that's why a lot of people who work at those big tech companies burn out, because everybody's using Agile these days. Okay, so that is the idea, the pros and the cons. If managed properly, Agile would probably be the way to go compared with Waterfall. Okay, unless you're trying to work on like flight software or like pacemakers or things like that. Okay, so again, Agile is all about moving fast. Release quickly, release often is their little mantra. Maybe I should put that in quotes, because that's really what they say. That's their catchphrase, and it's really nice because after you give one of these pre-releases to the customer, what they give you back, all of that feedback, is going to drive the next little cycle that you're in. And yeah, cycles are fast. They're about a month, give or take a couple weeks. Maybe a 6-week cycle is also normal. 2-week cycles are not unheard of. And these are called sprints, okay? Which makes it goes back to the stressful idea. So it's like, okay, we got to run really fast to get this stuff out the door in the time that we've given ourselves. Okay? So, yeah, these are called sprints. And what happens is the whole team works on this new feature that we're trying to get going along. We're following that cycle again. We code it up, design it, test it, give it to the client, make sure that it's working for them, get their feedback, and then we can come back to the drawing board after the sprint is finished after a month. Okay? So it's like 1 month. That is Agile Development. Okay? So if you've heard that buzzword before, now you know exactly what it means. It's just moving fast, coding, and getting feedback very quickly from the customer who's paying you to write all this code. All right. So let us talk about Waterfall versus Agile. I know I've like compared and contrasted a little bit, but let's go deep into this, because this is like the Emacs versus Vim of software engineering. So Waterfall versus Agile. Waterfall, remember what they're trying to do. They are chunking all of these different processes. First we get the requirements, then we design everything. Okay, we specify everything before we actually code. And what they're doing is you're coding something that you decided on like 4 months ago. So they're trying really hard in Waterfall to predict the future, and I think, as we all know, that doesn't end up well, usually. So that's Waterfall's idea of the best thing to do. Agile, on the other hand, is more about, okay, we have a month, let's respond to the last thing that the user told us. Okay, let's respond very quickly and get them something out the door quickly. Okay, it's about responding quickly to the present. Okay, so present versus future usually. And I guess my question to you is, because there is data behind this, people have chosen Waterfall methods, people have chosen Agile methods. There's been probably not millions, but thousands upon thousands of projects that have been completed in both of these methods. Which of the two do you think is better? Like, what are your thoughts? Which is more workable? And then I have some data to show you. Take your best guess. I am a bit biased, but I think most of us are. So the answer is that if you go the Agile route, it is 200 to 300% more likely that your project succeeds. More likely that your project actually succeeds versus the Waterfall method. And this might seem amazing, so we're always going to use Agile, but remember that Waterfall still has its place. And then also the word success I haven't really defined to you, so I'll show you that on the next slide. But yeah, usually Agile is the way to go. If you can get away with doing Agile, do it over Waterfall. Okay, that's the idea. So yeah, here we go. This is essentially what success means. You're successful if you weren't over budget or over time, right? And you also just didn't scrap the project, okay? So here is like what happens. Here is my little pie chart for you. So here's projects done, managed using the waterfall method, projects administered using the Agile method. And so they could have been successful, they got out the door to the user in the correct amount of time. They could have been challenged, which means that they noticed they needed more money or more time to do things. Or they failed, which means they just got scrapped. They were never given to the user in the end. All right? So that's waterfall versus Agile. Notice, much more likely to be successful. That's key. About the same amount are challenged. And I think that goes back to the original user at that point, because again, customers can't really pick what they need. They don't really understand their use cases until the software is ready. So usually they notice that they need something else, and so you need to take more time. The majority of the time, you need to take more time to work on something, which means usually that means you need more money. Okay, so that's usually the problem there. And then waterfall versus agile on field projects, it's much less likely, about almost 3 times less likely to fail. That's the idea. Okay, so you're getting stuff out the door and you can respond quickly to events. Agile is the way to go if you can do it. Okay, so that is Agile. Let us now talk about Scrum, which is another buzzword that I should tell you about. So it's a subtype of Agile that like has some extra ideas behind it. Okay, it's not just, okay, we're going to do this cycle real quick. They have some rules. Okay, so let me tell you about those extra rules. Okay, so this is very, very popular. Scrum is a very popular subtype of Agile that a lot of people like to use, or at least steal pieces from. And here's what happens. So what you do is you figure out like what it means for your project to be ready. Okay, ready to ship the next thing to the customer. So they establish what's called a definition of done, which a lot of the time it's something like, okay, the program passes all these tests that we wrote. We're done with this piece. Let's give it to the user. Let's do something. Okay, let's see what they say. And so that's nice because it gives you a way to actually explain, okay, the project is done now. We're ready to move on to the next piece. And it's hard to define that. So they came up with their definition. You can accept it or not. Okay. The thing that Scrum is really, really known for is this thing called a backlog. Okay, so just like for Waterfall, just like for Agile, you are making a bunch of requirements. You're making a list of all the things that you need to do. Scrum handles that list in a certain way. So they put all of these features, all these tasks that need to be done on what's called a backlog. Okay, that includes new features, it includes bug fixes that need to be performed, documentation writing, which is something nobody likes to do but still needs to be done. All that stuff gets put on this thing called a backlog, and then everybody works through the backlog. So at the beginning of their little sprints, the backlog is full of stuff, and then people go off and take things and like complete it. And so once it's done, they can move on. Okay, that's kind of the idea. And on this backlog, there's a lot more information. It's you give all these tasks a priority, a risk, like, ooh, this needs a lot of eyes, maybe, because it's hard to get right, and an estimated amount of time, which usually is never perfect, but it's at least an estimate. And then there's some acting involved. Okay, so there's a person that's just another programmer who's on your team, maybe part of the administration, and they're called the product owner. And so they pretend to be the client. Okay, they might actually go back and forth between the real client, but they're part of your team, and they pretend to be the client. They actually generate that backlog and all these priorities. Okay, that's the idea. Okay, so that is Scrum, and it's very, very useful. All right, so now comes to the things that Scrum is really known for. All right, so this is the stuff that if you don't use Scrum, usually you've heard about these things, and you maybe want to incorporate some of them into your own practices. So there's this concept of a Scrum Master, which is funny. It's kind of like a project manager, but what the Scrum Master does is they guide the process itself. Like, okay, we're generating this backlog, we're getting things done. They make sure that the process goes smoothly, okay? And they meet back and forth with the company's leadership to just make sure that everybody's on the same page. They try as hard as possible to make it so that you don't have to have a bunch of useless meetings when you're a developer. Okay, so that's what the Scrum Master does. They're like the people person. So maybe if you enjoy that kind of thing, this is a nice place to be, a nice job to have. You don't have to do a lot of programming, but you understand what developers are thinking, and you get to talk to a lot of people all day long. Okay, so that's the Scrum Master's job. And yeah, sprints for Scrum are fast. They're not a month, they're like 2 weeks, all right? And they get planned with a long-ish planning event where they take that backlog, they find all the tasks that have like high priority, and they make sure that they're towards the top and they get taken off the list and completed first. And so they take the real backlog and they make the sprint backlog. Okay, so like, we're doing this for this sprint. We're doing these few things, and then the rest can stay on the list. Okay? The most popular thing that Scrum does, it's this. Okay? This is what I've been leading towards, so drum roll please. What you do when you're using Scrum to develop software is you have very, very short meetings each day. You have like a 15-minute meeting, and it's usually called like a stand-up meeting or the daily Scrum, and you do this until the end of the sprint, and then you start all over again, of course. And during this meeting, each person that's working on the piece of software is going to tell everyone like what they did before, to just keep everybody accountable and make sure that everybody's on the same page, say what they're going to do today, and talk about any roadblocks that they have, so that maybe the Scrum Master can get involved if they need to, or two developers can coordinate if they need to, if they both need something finished before they can work on the next thing, things like that. So this is the most important feature of Scrum, in my opinion, and I think a lot of people would agree. So even if you are a Waterfall team, even if you're not really using Scrum the way it was meant to be used, like the way Wikipedia says, they usually steal this idea of very quick meetings just to get everybody on the same page. This was a key thing which was really not being done before, apparently. So that is Scrum. Okay? And yeah, after the meeting, usually it's at the beginning of the day, team members, like the developers, they just keep on working through this backlog that was developed by the Scrum Master, and they get all their little tasks done, all their silly little tasks. So that is Scrum in a nutshell. It has a lot of weird rules, but it's still quite popular because it gets work done. Okay, it gets the job done. Okay, so here's a nice graphic just explaining what's happening. You have a long product backlog with a bunch of features that need to get implemented for the project to be done, and then for each sprint, maybe it's a month, maybe it's 2 weeks, you pick out from this backlog a bite-sized chunk of things to do, to work on, and you'll iterate through that for the entire month or 2 weeks or whatever. Okay? And so you work on this backlog for 30 days, you have all these stand-up meetings every day, and people legitimately stand up, and it's supposed to be like that so that everybody gets out of the room as fast as possible because they don't want useless meetings. And then after that sprint is over, Agile and Scrum, they both give a piece of software that is, like, they produce a piece of software that's ready to be used. Okay, so that is Scrum, and this is kind of just Agile in a nutshell, really. Yeah, so very last slide about Scrum with words is at the end of their cycle, their sprints are 2 weeks, they have like a retrospective. They go and look at what they've done, okay? and they make sure that they accomplished what they wanted to accomplish. They ask questions like, okay, what did we do well? What happened that was like a roadblock that we can maybe prevent next time? Always thinking about the future. And yeah, then somebody's on the phone with the customer, like giving them the new increment of the software. Okay, the new alpha version or whatever. That is the beauty of it all. So yeah, Scrum is all about agile stuff, like moving quickly, and it's even more time limited, I think, is the goal of Scrum. So yeah, the whole point is that nobody likes meetings. They're trying to get out of as many as possible, and to make sure that you don't have to have a million product cycles before something's ready to be shipped to the customer. Okay? The shorter the better, so that you can respond quicker to changes. Okay? So that is Scrum, and that is all I have to write down about it. Here is an example of something that is used in Agile Development. You have what's called a burn down chart, where people get to see like all the tasks remaining. Like here is like how many tasks get completed each day, things like that. So maybe a couple days just people are working, and then finally some tasks start getting finished. That's the idea. And so here's like what is happening. There are this many tasks to do. Now some things got finished. There's this many tasks, this many tasks. And the goal is to get down to 0, of course, at the end of the sprint. And then they also like estimate the effort left, because each task has an amount of time associated with it. They estimate it's going to take, okay, 5 hours to do this, 7 hours to do this, things like that. And so these two things should move mostly hand in hand. And the whole goal is that you move down at a linear pace. Okay. Eventually you have 0 things left to do, and you're knocking stuff out every day. That is the goal of Agile Development and Scrum. Okay, so that is everything in a nutshell. You have to plan your stuff very, very well. If you want to work in Waterfall, you got to plan it all ahead. If you want to work in Agile, you plan as you go, kind of. Okay, so the final thing for this set of slides is a third kind of programming paradigm. Agile and Scrum are kind of one thing, in a sense. This is TDD. Okay, are you ready? It's a bit different than the other two. This is called test-driven development. And this one is pretty darn different from the other two. What this one does is it takes that cycle and it's like, you know what, I'm going to reorder this. I'm going to reorder these steps. 2 important steps get flip-flopped. In test-driven development, you swap the testing phase and the coding phase. You actually write your tests before you ever write the code. Okay? I may have hinted at this a little while ago, but this is the real deal now. We're going to talk about TDD. So the reason this is nice is because while you're writing the tests, you kind of get to figure out, okay, this is what the return type should be, this should be what the parameters are. Like, you get to figure out, because you have to pretend that these exist and use them, you got to figure out how the functions and classes that you're going to write are going to be used. That's really, really helpful. Okay? That's quite nice, and that will actually guide you. The tests will guide you, they should, as you really go and implement the things, because you're writing code after you've written the tests. Okay? So they have their own little lingo, and you don't really have to remember this, but it's what they like to say. So before you start implementing, all the tests don't pass. They fail. They're red. Okay? That's just what their term is for failing tests. They're all red. Okay? And then every time you implement a new thing, more of the tests will start turning green, which means they pass. Isn't that nice? So yeah, after you've gotten all the tests to pass, you're not done. And like the labs in this class, you're mostly done, but because that's how your grade gets like made. But usually, after you've gotten these tests to pass, your code is kind of ugly looking, and so you refactor it. The word for cleaning up code is refactoring, and so you just make it prettier, make it more logical looking, document it. Everything you need to do to just make it so that another human can look at it and not yell at you about it. Okay, so that is the process of test-driven development. Write all the tests. First, they're all failing. Then they all pass, and then you refactor the code. Okay, and then it's time to work on the next feature. Figure out its test cases. Start implementing it. And so their catchphrase is red, green, refactor. Okay, that's their 3-step process. Okay, so you got your failing tests that you wrote, then you implement things to get them to pass, and then you refactor your code to make it prettier. Okay, so that's TDD in a nutshell. And yeah, it's quite different. That testing phase coming first throws a lot of people off. It doesn't really make sense in our minds, right? But it has its place, especially in a school environment. So the pros of TDD is if you have a good enough test suite, like if I make a good enough test suite for your lab, then you can be sure that all of the stuff that you're about to implement doesn't break the old stuff, because those have their own tests. Everything's working, right? And so hopefully once you get them all to pass, I should give you a good grade, right? And another nice feature of TDD is that you can break things. It's okay. If you break something, you're probably going to have a previous version of your code that you can go back to, so you can be quite brave. Okay, this is something that most people do. It's called just keeping revision histories of code, and TDD is all about this. Okay, they want you to go off and get a test to pass, and maybe that wasn't the right way, and the rest of the tests won't pass because of what you did, but you can undo. You can be brave. Okay, so that sometimes results in cleaner code in the end. Okay, so that's pros of TDD. Cons, though, are a few. So it takes a long time to run tests, because imagine you're writing a huge piece of code that's supposed to take a year long to make. You're going to write thousands, tens of thousands of tests, right? If not more. So it's going to take a long time to run these tests to make sure that what you just changed didn't break the other stuff. So that is unfortunate. And a lot of people, they get around this by having a server, and they run all of their tests just at night while nobody's working. Okay. And so the next morning they're ready to see, okay, what broke? What do we have to fix again? Okay. So that's a con. And then there's also the idea of the person who's writing the code probably also wrote those tests that are supposed to test the code, which is unfortunate, because that means there might be holes. Okay, there might be things that you didn't think of as the programmer who wrote the tests, and then you implemented things. Okay, you didn't notice that there's a huge gaping hole because it was just your eyes, and you just couldn't see this issue. When maybe if somebody else wrote the tests and you wrote the code, you might have figured out. Okay, so that's nice. The other unfortunate thing about writing tests early is they probably need to be updated. You're going to have a ton of them, and they need to be updated when you start changing your requirements, you start changing your code around, which is unfortunate. And it's just a fact of life. But when TDD revolves around these tests, you have to spend a whole lot more time worrying about them. Okay, I would say. And yeah, that's TDD's cons. The final one is, if you're writing a game, a piece of software that is based around an experience, okay, I want to make sure this website looks nice. You can't really test that. Okay, you can't test okay, yeah, that was fun. There's no way of doing that. That's easy. Okay, you can't write a test for these things. So that is unfortunate, but that's okay. You don't have to use every feature of test-driven development. You want to pick and choose from each of these paradigms, and that's why I'm teaching them all to you. Okay, so yeah, before we go, I want to make 2 functions for you, and we're going to use TDD to get there. All right, we're going to practice using our bitwise operations. So I'm going to make a set third bit function. So it's going to be void set third bit. And it's I don't know, int reference n, because we want to change this number. So that'll set the third bit of n if it's not already set. And then we're going to get a is third bit set function to return true or false, depending on whether a number n's third bit has been set. and I'm going to walk you through the TDD style of doing this. Okay, so the whole idea is that you start your code out as stubs so that you can have your tests immediately fail. Okay, you need code there to make them fail first. Okay, so that's why I give you a bunch of stubs. Let's do this. All right, so I'm in this new folder for today. Did I also change directories here? Not yet. Cool. Let's make a nice test-driven development file. So let's do, I don't know, let's do third or more bitwise stuff. I'm not sure what to name this file. Bits.cvv. How about that? That works for me. So here's the idea. Here's what we want to do. We want to have these functions, right? Set third bit is third bit set. Pass it by reference because we need to change that. And then bool is third bit set of a number that you give. It doesn't have to be by reference this time. And so these functions, they start out as stubs, okay? And then implement them slowly to pass the tests. All right, so the first things that we can do here is nothing for the void function. It can get called and do nothing. And then is third bit set needs to give back a bool, so let's say true every time. Okay, so these are stubs now. They don't do the right thing, but at least we can call them in our tests. Okay, so now we have test stuff. So you have usually, let's have the test function that we know and love. Assert true, assert that a Boolean value is true, and we'll say something like if b cout passed, else we say failed. All right, and so now let's make a bunch of tests. So I don't know, void test set third bit, and void test is third bit set. So I'm going to write a ton of tests here. Usually you'll make multiple functions, one for each test, but I'm going to be lazy. Okay, so let's test. Let's make sure that setting the third bit of 0 makes a certain number. Int x equals 0, and let's set the third bit of 0, of x, and so x has changed, its third bit is set. That's the only bit that's set, so x is 1, 0, 0, 0, because that's the third bit, so it's equal to 8 right now. So we need to assert true that x is now equal to 8, okay? Okay, that's the idea. And then we can keep going. We should also assert true that if you do it again, it doesn't change anything. The third bit should stay set. So again, so the third bit of 8, nothing should change. Okay, so that's the idea. That's what should happen. Here are 2 tests, for example. And then let's test, is the third bit set? So, well, I have a number, how about the number 9? 9 is 1, 0, 0, 1. 9 has its third bit set, right? So assert that the third bit of 9 is set is true. So that's one test. Then you can do similar things with other numbers, like assert that the third bit of like 5 is not set. So this should not be true. It should be equal to false. Things like that. Okay, so here are 4 tests total, and some of them will actually pass with these steps. Are you ready? So let's see here. That is the goal. Or actually, to make even more of them pass, how about let's say int z equals 8. So z should stay 8 in this case. So that's going to be fun. Okay, are you ready? Let's just do G++ this time. Oh shoot, I have to call these, don't I? Excuse me. So test set third bit. Test is third bit set. That's useful. Hey, and so a lot of them pass, like setting the third bit of 8. Yeah, if it's already set, of course, it's going to stay 8. That's fine. But the first one failed, because we haven't done anything yet. Okay, the third bit of 9, yes, it is set. And we're always returning true, okay? But 5 has no third bit. It's set to 0. So that one should be false, and that test fails, okay? So here are some red tests. Let's make them green. And I don't think there's any refactoring necessary for this one, but I think you get the idea. Okay, so set the third bit. You just say n equals n or 1 to the 3. Yeah, that's the beauty of it. And then is third bit set, you return is n and 1 to the 3, because that's the number with just the third bit set. You and it with n. So if this is a non-zero number, that means that bit really was set because it picked it out. So those are the 2 implementations. Now we have passing tests, and we're very confident in our code. Okay, and so it was useful to write those tests first. So that's my quick little story for test-driven development. Hopefully it makes sense to you as to why I'm using it in class. Okay, so if you would like to practice further, here are some exercises for you. So I encourage you to try out test-driven development. If I ask you to write tests, or even if I don't, write your own. It'll help you understand the problem a whole lot more, I think. Because I needed to know, like, to make these tests, how these functions were going to be used, what they meant, and that was key. Okay, so write the tests. Try writing the tests before you implement anything else. Look at the tests that I've written if I've given you some. So that's something nice. And then also, if you are working on a pair for your labs right now, I really encourage you to take some of those pieces of Scrum, especially those quick daily meetings, to just meet up with your partner and make sure that everybody's on the same page and like you've got your plan settled and you understand what's been done and needs to be done. Okay, so that is all I have for you. So hopefully this was fun. This was a different kind of lecture than usual. More talking, less writing code. But I think it was useful to understand because a lot of people are using these buzzwords all over the place. So now you know about them. Okay, so that is bitwise operators and programming paradigms. So that's all I have for you. Please yell at me if you have any questions, and I will see you later.